Given the matrix M, find M inverse, the inverse of M. Now it is always given like this, which symbolizes the inverse of the matrix M. Yet we are still told that it represents the inverse of M. We cannot miss. We are sure of the requirement of this problem. M is equal to 2, 1, 4, 3. We read a matrix row by row. So that is 2, 1, 4, 3, and we are required to find its inverse. In finding the inverse of M, we will make use of a template. And the template is saying 1 over the determinant multiplied by the adjoint, and we have the matrix here, which is not a part of the solution. It is not necessary to keep the matrix M nearby. It is being done as a part of the visual effects of the animation and nothing else. Therefore, it is not a part of the solution, and we will discard of it when we get to the right place. For now, we are just keeping it nearby in order to show the animation of how we arrive at the determinant. The inverse of a matrix is 1 over the determinant multiplied by the adjoint. 1 over the determinant times the adjoint. The determinant is the product of the leading diagonal minus the product of the subordinate diagonal. The product of the leading diagonal, 2 times 3, will go there. Then we will subtract the subtraction sign. Look out for it. There it is. Because once it gets to its rightful place, we might not see that so easily. Minus the product of the subordinate diagonal. There we go. Product of 1 and 4. The adjoint. How is the adjoint formed? The adjoint is formed by exchanging places of the elements of the leading diagonal and changing the signs of the elements in the subordinate diagonal. Adjoint. The leading diagonal, those will exchange places. The subordinate diagonal, these will exchange signs. These are positive at the moment. We will assign to them negative signs. There we have our adjoint, and consequently the inverse of the matrix, and we would have removed the original matrix that we are using as a shadow to the entire process. We will remove that one. Notice that what we have here is the adjoint. We are therefore simplifying this to this. And the only simplification that will be done at the moment is 2 3's, 6, minus 1, 4, 4. 6 minus 4 is 2. Therefore, a half belongs right there. The fraction simplifies to a half. Then, we will take half of each of the elements, which of course, that means we are multiplying by a half, and multiplying by a half is the same as dividing by 2. Each element is therefore divided by 2. These will remain in their fractional form, the 3 over 2, the negative 1 over 2. However, because these simplify, these two will simplify this one to give a negative 2 and this one to give a positive 1, then we may go straight ahead and simplify. 3 over 2 negative a half and negative 2 1. That is our inverse matrix of M, which is equal to 2 1 0.43. When using the inverse matrix in calculations, it might be judicious to take the fraction outside of the matrix. Therefore, if we are required to use this, which of course we most certainly will be required to use it, then we should not use it in this form. You could, but it is going to be too cumbersome and too mentally overwhelming. When we are required to use this inverse in another process, we will take this version of the inverse, meaning that we are taking the half outside of the matrix so that our manipulation will be entirely off whole numbers. In the end, the half will be applied. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.